Okay, this video is going to be over Unit 8, Section 3, which has to do with cones in pyramids. So our objectives are to learn and apply the formulas for the volume of a pyramid and the volume of a cone. So the first thing we need to talk about is the formula for the volume of a cone. This differs from the volume of a cylinder in that a cone's volume is 1/3 of a cylinder with the same base. So if you notice, the base of both the cylinder and the cone is a circle. We see this right here. Now, if we had a cylinder that was like this cone, same height basically, then that cone would be 1/3 the volume of the corresponding cylinder. So here again, the two variables we need are the radius and the height. That's what our R and our H are. And we're going to take 1/3 of the radius squared times the height and then multiply that by pi. When we're doing the volume of a cone, we're going to always give our answer in two different ways, one with pi in it and then one with when we multiply by pi. So with this first problem, it says find the volume of a cone with a radius of 7 centimeters and a height of 15 centimeters. Give your answer both in terms of pi and rounded to the nearest tenth. So we have that our radius is 7 and our height is 15 centimeters. So we're going to use our formula, volume equals pi r squared, which we can find on our formula sheet. And then we're going to populate that formula. So our r is our radius, that's 7 up here. And our h is 15, which is our height. So we're going to multiply 7 squared times 15. And then I want you guys to recall that multiplying by 1/3 is the same as dividing by 3. So oftentimes when I do this problem, I do it this way. 7 squared times 15 divided by 3, and then I multiply that by pi, because again, that's how we're going to get our answer. 7 squared times 15 divided by 3, and then we're going to multiply that by pi. And so we're going to have our two answers. When we do 49 times 15 divided by 3, that's 245 pi centimeters cubed. And remember, we're always going to cube our unit because this is a three-dimensional object. Then when we multiply by pi here, we get 769.7 centimeters cubed. Our next one has to do with the volume of a cone with a base circumference. Now, not sure whether you guys remember this or not, but circumference is the length around or the perimeter around a circle. So if you'll find on your formula sheet the formula for circumference, we're going to use that here because it says here that our height is 2 inches more than twice the radius. So to be able to find both the radius and the height, which are the two variables we need for this problem, we got to find the radius first. So we're going to use that formula for circumference, and that's circumference is equal to 2 pi r. There is another formula, which is d pi, which is the diameter times pi, but we need r here, so we're going to use that formula. So we're going to put 25 pi in here, and that's going to be equal to 2 pi r. We're going to divide both sides by 2 pi. And when we do that, the 2 pi cancels out from over there, so we're left with r. And over here, the pi cancels out, and so we're going to divide 25 by 2. That's 12.5. Then if you notice in this problem, it tells us that the height is 2 inches more than twice the radius. So we have to think about, what does 2 inches more mean? So I know that more means plus 2, because it says it's 2 inches more. And then when it says twice the radius, we know that that's going to be 2 times the radius. So now we need to write a formula for the height of this cone. So the height is equal to 2 times the radius plus 2 more inches. So our radius was 12.5, so we're going to do 2 times 12.5, and then we're going to add 2 to that. 2 times 12.5 is 25, and that's going to be, add 2 to it, so our height is going to be equal to 27. Now we're going to go ahead and use our volume formula, because now we have, sorry about that, now we have, where in the world did we go? Now we have our radius and our height. So volume is equal to, and I'm going to do this the way I would do it, which would be r squared times the height divided by 3 times pi. So I like to do it this way because then I'm doing everything that doesn't have pi included in it first. And I like to divide by 3 instead of multiplying by 1/3 because I just think it's easier. So we're going to do our r squared, which was 12.5. And we're going to multiply that times our height, which was 27. We're going to divide all that by 3 and multiply it by pi. So now when I square my 12.5 and I multiply it times 27 and I divide it by 3, I get to this 1,406.25 pi. And again, this is inches up here, so we're going to do our unit cubed. Then when I multiply that number by pi, I get 44,417.9, and this is inches cubed as well. So this is the harder type of problem when we actually have to find the height and the radius before proceeding with the problem. So let's look at the next one. So this one is to find the volume of the cone. Now, to find the volume of this cone, we need the radius and the height. We have the radius, it's right here. So r equals 16. However, we do not have the height. This is our height right here. So we need to find h. So to find h, we're going to use Pythagorean's theorem because I noticed this is a right triangle. And I also realized that that number over there, that 34, is equal to my c. Now I could make this 16 a or b, but I'm going to go ahead and make it a. So then I'm going to actually use Pythagorean's theorem to find the height. So I'm going to do 16 squared plus h squared equals 34.2 squared. So when I subtract the 16 squared from the 34 squared, I get 900. When I take the square root of both of these sides, which is what I would do here, take the square root of both sides, I'm going to get that h is equal to 30. Then I'm just going to plug that back into my formula. So when I do that here, again, volume is equal to pi r squared h divided by 3 or times 1/3. So I'm going to go ahead and populate the formula here. That would be 16 squared times 30 divided by 3. That gives me 2560 pi centimeters cubed. Again, my units cubed. And then when I multiply that number by pi, I get 8,042.5 centimeters cubed. All right, now I want you to work the next two problems and then come back to me. Okay, again, so for volume of a cone, I need two variables, radius and height. I notice that I do have the height. This is my height right here, but I don't have the radius. I have the diameter. I just remember that the diameter is twice the radius. So that means both of these would have to be 9 and 9. So my radius is 9. So again, we're going to plug the radius and the height into this problem. So that's 9 squared times 8 divided by 3. That's going to give me my answer with pi in it, 216 pi meters cubed. And then I'm going to multiply that by pi. That's 678.6 meters cubed. My next problem says find the volume of a cone with a base of 36 pi feet. Okay, so base. Now I happen to remember that the base of a cone is a circle. So we're talking about the area of a base. So what we want to do first is find the radius again, because it says here again that our height is equal to twice the radius. So we got to find the radius to be able to find the height. So here again, we're going to work this problem. We're going to find the area. Area is equal to pi r squared. That's 36 pi. That's equal to pi r squared. We're going to divide both sides by pi. That's going to make pi cancel out on both sides. Then we're going to take the square root of 36 and r squared, and that means r is equal to 6. It tells us here too that the height is twice the radius. So we know that our height is 2 times 6, which is 12. Then all we have to do is plug those two values back in. So when we do that, we get 6 squared times 12 divided by 3. That's 144 pi feet cubed. And when we multiply this 144 by pi, we get 452.4 feet cubed. Again, these are the harder problems when we have to find r to be able to find the height. All right, our next problem says we're going to explore the effects. Now again, key word here is effects of changing dimensions. So this says that the diameter and the height of a cone are divided by 3. Now we've already talked about the fact that when we divide by 3, it's the same as multiplying by 1/3. So I want to go ahead and put 1/3 up here. And we're going to talk about, if we're talking about volume, we are cubing this number. So that means we're going to multiply 1 times 1 times 1, that's 1. When we multiply 3 times 3, that's 9, times another 3, that's 27. So if we want to find out what the effect is, this shape is going to get 1/27th the size of its original. So it's going to get smaller by 1/27th. So then also, if we want to talk about how does the volume actually change? Well, we could find the volume of the original. And so let's go ahead and do that here. If we go ahead and find the volume, we know that that was 1/27th. We talked about that. So if we find the volume of the original, it was 281.25 pi. That's the volume of the original object. And again, if you notice here, we have a diameter, so the radius would be 7.5. So if we find the original volume, then what we can do with that is we can actually just divide that number by 27, and that will give us the volume of the new image, of the new shape. So when we do that, remember, multiplying by 1 over 27 is the same as dividing by 27. So that gives us 10.42 pi. So the effect is that it's 1/27th of the original, and the actual new volume would be 10.42 pi because we divided the original volume by 27. So let's look at this next one. This one says that the cone is doubled. Both the radius and the height of the cone are doubled. So when we double both the radius and the height, we're going to take that 2 and we're going to cube it again because it's a three-dimensional object. 2 times 2 is 4 times another 2 is 8. So this one is going to get 8 times bigger this time. So again, we can find the volume of the original. And when we find the volume of the original, we see that that's 486 pi centimeters cubed. Then we can take this number right here to find the new one and multiply it times 8. When we do that, we get that the new volume is 3,888 pi centimeters cubed. So we're going to find out what the effect is. The effect is that the shape's getting 8 times bigger. If we have the original volume, or if we found the original volume, the way we find the new volume is we multiply it times that 8. So when it's getting bigger, in this case it was getting 8 times bigger, we're going to multiply it. When it's getting smaller, if it's just a one-dimensional change, then it's going to be divided. All right, so when we talk about the volume of a pyramid, it's related to the volume of a prism. So as it was with the cone can relate to the cylinder. Here we can relate the prism and a pyramid. And if you notice here, we've got 3 different sides here, and these 3 different sides would produce 3 different pyramids that would fill up the full shape of whatever this prism is. So again, we're going to find the base times the height. Base, whatever the shape of the base is. It could be a square, it could be a rectangle, it could be a triangle. Whatever it is, we're going to find the area of the base first. We're going to multiply that times the height, and then we're just going to divide that number by 3. So here again, we've got that our volume for the rectangular prism was 11. We're going to multiply the 11 times the 18. That's our base. Multiply that times our height, and then we're going to divide that whole number by 3. Again, remember, multiplying by 1/3 is the same as dividing by 3. So that gives us 1,518 meters cubed. On the next problem, here again, we've got a square this time. So we've got the same dimension for both our length and our width, or our base and our height. So that's 9 times 9, and our height here was 14. So we're going to do 9 times 9 times 14, and then we're going to divide that number by 3 again. That's going to give us 378 centimeters cubed. So I want you guys to go ahead and try to do the other 2 problems and then come back to me when you're done. All right, so this next one, again, we've got 6 times 4, that's our base. Our height is 17. 6 times 4 times 17 divided by 3, that's going to give us 136 inches cubed. The next problem says a regular square pyramid with a base length of 12. So I'm going to go ahead and draw this one to the best of my ability. This is not one of my strengths, y'all, drawing a pyramid. So I'm going to draw a triangle there, triangle there. I'm going to leave that one in the back the way it is. Okay, so this means this is 12 and this is 12. And our height here is 10. So here again, we've got a 12 by 12 base because the base is a square. Notice here it says square. Whoops. That was an ugly line, y'all. and it's not going to let me erase it. So here we go. There, it says square there. So it's 12 by 12 times 10, and we're going to divide that by 3 again. So 12 times 12 times 10. So when it says slant height here, if it says height, we're good to go. So that's going to be 480 feet cubed. So now the next one says find the volume of a pyramid with a base of 6 by 4 and a doubled height. So this problem says the only dimension that we're changing now is the height. So if the height's doubled, 17 times 2 is 34. So that's the height we're going to use. So we're going to again do length times width, 6 times 4, times a doubled height, which is going to be 34, and divide that whole number by 3. And that's going to give us 272 inches cubed. So now, we again are going to talk about some cross sections. So that blank on your page is cross sections. So if we look here, it says the plane is parallel to the base of the cone. So the base of the cone is a circle. So if we cut that circle horizontally anywhere, we're going to get a circle. Again, if we cut that cone perpendicular to the base or vertically, then we're going to get a triangle. So here's a triangular prism. And on this one, again, if we cut it down the middle here, we just take a knife and cut it, then we can see what our cross section is going to be. It's going to be a triangle. On the next one, if we cut this triangular prism horizontally, again, we can see the shape right here. It's a rectangle. If we cut this cone horizontally, we get a circle. We already talked about this one. And the next one, vertically, we get a triangle. Now, the last thing we're going to talk about is if we took a right triangle and we rotated it 360 degrees. So if we take this right triangle and we rotate it 360 degrees, we're going to get a cone. Now, I want to show you all a video of this. We're going to take a right triangle and we're going to go ahead and rotate it 360 degrees. And y'all can watch here as we can see that we can now see that this is a cone. So that was an illustration of a right triangle being spun around 360 degrees and it creating the shape of a cone.